Hello students, this is Pavan Vijayavargiya again trying to give you some concept for the motion upon an inclined plane. Motion, we are studying one-dimensional motion, and we had studied motion under the gravity when an object is falling from some height or it is thrown in vertically upward direction. This time we are taking one-dimensional motion on an inclined plane, whether it is allowed to slip over inclined plane or it has been projected along the inclined plane. Here we will take acceleration of the body along its direction of motion to be a component of acceleration due to gravity. In some cases, we may be asked to solve such problems in which a particle is sliding from an inclined plane from up the incline to down the incline, and it may also occur that we have been asked for a particle moving along a groove on inclined plane, which is shown here. In this case, I have shown you that along this groove, if particle moves, then its acceleration is g sin theta cos alpha, where alpha is the angle of groove made by the line of greatest slope. In some other cases also, we will be using the concepts of one-dimensional motion to solve these parameters. First of all, I would like to introduce you some informations about inclined plane. I know you all may know this, but I am explaining this fact to you so that if any of you doesn't know this, then we may remove some confusions regarding this inclined plane. Some terminology which I will use further in solving these type of problems. I would also like to give some detail about that. Any plane which is inclined to the horizontal at a definite angle is said to be an inclined plane, and the corresponding angle of inclination is theta, which I have shown here. If we draw a line along the incline Pn, this line Pn makes the same angle with this line Mn is base of the inclined plane forms with this side BC. So this is the angle of inclination here, which I have showed here as theta. This line PM is perpendicular to the base, or we can say it is vertical. Here the line PN is said to be the line of greatest slope, because on this incline slope can never be more than slope of this line. If we conclude this angle in form of the length Pn and height Pm, then we can easily say that sin theta is equal to Pm, length of line Pm, divided by the length of line Pn. Here Pn is the height of point P from the ground, so I have taken it to be h, and the line Pn, which is the line of greatest slope, it is, I am taking L. So sin theta here is equal to h upon L. The inclination is often referred to as h in L. It implies that a h in L inclination is such that there is rise of h units for every L unit distance travelled along the plane. Here this is the height h, which particle rises in travelling this distance L up the incline.